this is Antonio back here, and today in episode 15 of our crash course in chemistry, we're talking about volumetric analysis. Now, volumetric analysis is unmistakenly a very easily very important in chemistry, because you have the whole of chemistry practical, or rather about roughly half of chemistry practical in WAEC is devoted to volumetric analysis. And volumetric analysis basically is the analysis, or rather the decomposition and breaking down or studying of chemical substances by understanding the volumes with which they react together. So, and then we cannot talk about volumetric analysis without talking about the units of volumes and other dimensions in volumetric analysis. We'll talk about standard and molar solutions. We'll have to talk about titration and then indicators. So we'll talk about these four in this video, and stay tuned and let's dive into chemistry. So now, volumetric analysis, we'll have to talk about the units. Now, the unit of volume could be in decimeter cube, it will be in centimeter cube. But just remember that 1000 centimeter cube makes 1 decimeter cube. So I've seen situations in exams when students mistake the volumes, and because of the wrong conversion, you miss the answer. So always remember that 1000 centimeter cube make 1 decimeter cube. And in addition to that, the unit of pressure is millimeter mercury, which is standard millimeter mercury. You can also measure pressure in terms of ATM. Yes, atmospheric pressure. So that will be 1.01 times 10 to the power 1.01 times 10 to the power 5 pascals. That's the unit of pressure. So this 760 millimeter mercury can also be converted to a bar. A bar is also equals to 1.01 times 10 to the power 5 ATM. So now that's atmospheric pressure. Then we also have the unit of temperature, which is standardly in Kelvin. So for you to be on the safest side in your examinations, always convert your temperature units to Kelvin, because that is the standard one in which your gas constant is specified and named. And also we have standard and molar solutions. A standard solution is a solution of known concentration. So if your teacher drops a solution of acid in water now and then tells you the concentration, so, and most of the time in your WAEC examinations you always have standard concentration. So, and it's also possible for you to be able to predict your values using the standard concentration of your solution. So more on that later. I'll make a series I'll make a further series on WAEC practicals, how to predict the value, and all about your practicals in chemistry. So, but today we are just going through a fundamental basics of volumetric analysis. So now, a standard solution is a solution of known concentration. Then we also have a molar solution. A molar solution is a solution whose concentration is 1 molar. So it's often represented by 1m in capital letters. So what this means is that in this standard solution you have 1 mole of the of the solute in 1000 centimeter cube of the solvent. So what that means is 1 mole in 1000 cm cube. But you see, I said 1000 cm cube is also equals to 1 decimeter cube. So that will be 1 mole. That's also 1 mole in 1 dm cube. So you often see it in this form expressed in dm cube, 1 mole per dm cube. That's the molar solution. Then you have your titration. Now in titration is simply the process whereby you combine your acid with your base in the presence of an indicator, and note it's a suitable indicator. When you combine your acid and base, it forms the indicator changes color at the end point, and then you measure the respective volumes of the acids and bases that are used in getting the end point. So, and in titration you also have your final reading, your initial reading. So you subtract your final from your initial to get the volume of acid used, and so you repeat your experiment a number of times. So basically it simply involves, when you have your beaker, the first thing you do is put your base inside your beaker, and then you add your indicator. For a strong acid and a strong base, you often use a methyl red or methyl orange. Then for your weak acid and strong base, you use phenolphthalein. Then for your strong acid and weak base, you often use methyl red or methyl orange. But actually, for your strong acid and strong base, you can use any suitable indicator. So you can use methyl orange, you can use methyl red, you can use Congo red, you can use litmus. So that's for strong acid and strong base. So those indicators, it varies depending on the acid and base. So it depends on the strength of the acid and the strength of the base. Now the strength of an acid or base is not dependent on the basicity. It's basically an inherent property of the acid. Now I don't know whether you've ever heard of what is called pKa of an acid. That is the solubility constant of an acid. So the higher that pKa, the lower the strength of the acid. The lower that pKa, the higher the strength of the acid. So that pKa is also a measure of the strength of the acid, not the basicity. The basicity does not have anything to do with the strength of the acid. So let's move on. That titration. So in titration, you often make use of your burette. So inside your burette, you put your acid, you fill it to the brim, and then you begin to open the tap small so that the acid can drop into the base, the mixture of the base and the indicator, and the base and the indicator will be in a burette under the so the base and the indicator will be in a burette under in a beaker, under the burette where the acid is. So and then when you immediately notice a change of color, you stop the tap and then you measure the final reading. Then when you subtract the final from the initial, you get the volume of acid used, and it is this volume of acid used that is used in an equation. Now this is the master equation for your chemistry practicals and in volumetric analysis. So in this equation is Ca Va over Cb Pb is equals to Na over Nb. So what this means is that the concentration of the acid is Ca, the volume of the acid is Va, the concentration of the base is Cb, the volume of the base is Vb, the concentration, the number of moles of the acid is Na, and the number of moles of the base is Nb. So and then your Na and Nb are actually gotten from your equation of the reaction. Why often involves an equation of reaction. If you are not given, you can formulate one yourself, because most of these chemical reactions, or this is specifically known as neutralization. So you can also be given a redox reaction to solve instead of your acid base neutralization. But in either case, you are still going to make the same techniques using the number of moles of the so in the case you are given a redox reaction, you say the concentration of the oxidizing agent times the volume of the oxidizing agent over the concentration of the reducing agent, volume of reducing agent, will be equal to the number of moles of the oxidizing agent over number of moles of the reducing agent. So in this case, just change your acid into oxidizing agent and change the base to reducing agent, and it is still the same technique, I promise you. So that is basically what you do in titration. And then when you've done, and as I mentioned earlier, your number of moles is gotten from your equation. Then your in these equations, there's often one value which is missing, so it is that value you solve for, and then your YX is graded according to the accuracy of that value. Then lastly, we'll talk about indicators. I've been talking about titration, but without indicators, titration will not be successful. So indicators are basically those weak organic acids or bases that are very quick to tell us a change in the pH. So they are basically the weak organic acid and bases that gives us a change in color whenever the pH of the reaction has coincided with the pH of the indicator. So the only reason why an indicator changes color is because the pH of the indicator coincides with the pH of the acid. So it is that point at which there is a color change. So and that is how indicators work. So to sum up this video, we talked about units of in volumetric analysis. We've talked about standard and molar solutions. We've talked about titration, which is basically your neutralization reaction or your redox reaction, or it can be any reaction that involves an oxidizing and reducing agent. Then we have talked about indicators. Thank you for watching.